So the title of Michael's talk is the Lunar Environment Heliospheric X-ray Imager. And Michael is from NASA Goddard. So Michael, if you're on, would you please start your talk?
Sure, copy that. I'll go ahead while Bob and Ricky work out the
sliding
issues there. So can you,
yes,
obviously you can hear me, I guess, can you verify that you're seeing slide 1?
Right, in the presentation mode.
Okay, excellent. Would you like me to proceed?
Yes, please.
Okay, copy that. My name is Mike Collier, and I'm gonna talk today about LEXI, the Lunar Environment Heliospheric X-ray Imager, which is a wide field of view soft X-ray imager. Now, LEXI will be one of 10 CLPS, Commercial Lunar Payload Services, instruments hosted by the FIREFLY AERO-SPACE Blue Ghost Mission 1 vehicle, with an anticipated landing in the second half of 2023 at Mare Crisium. LEXI is led by Principal Investigator Brian Walsh, who is a professor at Boston University, and it includes 6 other institutions, which are shown in the upper right in this slide. LEXI will observe the solar wind magnetosphere interaction from the surface of the moon to address outstanding problems in heliophysics, such as, for example, the nature of magnetic reconnection. LEXI detects solar wind charge exchange, SWIX for short, soft X-ray emission. In the mid-1990s, the ROSAT spacecraft imaged Comet Yakutaki in soft X-rays. See figure 2A in the upper left. Now, X-rays are usually associated with very hot objects, and comets clearly are not hot, they're balls of ice. Thus, it's quite a surprise, or was quite a surprise at the time, when ROSAT detected unexpectedly large amounts of soft X-ray emission coming from Comet Yakutaki. Now, this mystery was solved by Tom Cravens at the University of Kansas, who's also a member of our LEXI team. Referring to figure 2B in the lower right, high charge state heavy ions in the solar wind, such as oxygen +8, interact with cometary neutral atoms and steal an electron, charge exchange. Afterwards, the heavy ion is in an excited state, and when that excited state relaxes, soft X-rays, X-rays below about 1 keV, are emitted. Solar wind charge exchange occurs not just at comets, but everywhere in the heliosphere that the solar wind encounters neutral gas. At Earth, in particular, the exosphere extends beyond the magnetopause, the boundary at the edge of the magnetosphere, through which all solar wind momentum and energy powering space weather must pass. So the solar wind interaction with Earth creates a soft X-ray signal, as shown in figure 3A in the upper left. Now, at this point, we understand solar wind charge exchange emission well enough to perform accurate simulations. The lower images on this slide, figures 3B and 3C, show simulations of the soft X-ray emission from the solar wind interaction with Earth. Now, we can identify features in the images such as the cusps, which are the bright red in figure 3B. But most importantly for our purposes, we can image the inner boundary of the emission, which is the magnetopause, indicated in figure 3C, and LEXI's target. So to provide just one example of why we would want to image the magnetopause, the process of magnetic reconnection, which rearranges magnetic topology, is the major mode of transferring the energy that drives space weather from the solar wind into the magnetosphere, and it's illustrated by figure 4a. One aspect of magnetic reconnection that we do not fully understand is its temporal nature. That is, does the process occur quickly, slowly, or in bursts? Now, because magnetic reconnection moves the location of the subsolar magnetopause inward, by determining the location of the magnetopause versus time, we can deduce the temporal nature of magnetic reconnection, as shown in figure 4b. Now, the concept of soft X-ray imaging from the surface of the moon goes back over a decade to the vision for space exploration. At that time, NASA funded several concept studies through LSSO, the Lunar Sortie Science Opportunities Program. These are also sometimes referred to as suitcase science packages. At least colloquially, they were referred to as those at the time. And like the Apollo Lunar Surface Experiments Package, or ALSAP, which is shown in figure 5a, astronauts would place instruments, such as an X-ray imager, on the surface of the moon to take measurements. Our original LSSO concept is shown here in figure 5b in the upper right, and figure 5c shows how magnetosheath soft X-ray emission will appear from the surface of the moon. Solar wind charge exchange soft X-ray emission had been observed and has been observed by astrophysical telescopes designed to image distant angularly small objects. Now, for magnetopause imaging, we needed a wide field of view soft X-ray imager, which we developed, and that's shown in figure 6a and 6b. And we flew as a piggyback on the diffuse X-ray emission from the local galaxy, or DXL sounding rocket, led by Massimiliano Galeazzi at the University of Florida. The purpose of the DXL mission was to observe solar wind charge exchange from another source, the interstellar helium focusing cone. The soft X-ray imager prototype was launched from White Sands Missile Range on December 12, 2012, and performed flawlessly, in spite of its Black Brant rocket experiencing, quote, serious thrust anomalies, end quote, which resulted in a very rough ride. Because this was the first flight ever in space of a wide field of view soft X-ray imager, our team got an invited article in Review of Scientific Instruments, along with the cover of the journal, which we show in figure 6c. So we are currently refurbishing our soft X-ray imager to go on the FIREFLY AERO-SPACE Blue Ghost Mission 1. And figure 7a and 7b show the current refurbished instruments. Some enhancements we're making to the LEXI instrument to improve its performance for this lunar application include adding baffles to increase the signal to noise, that's figure 7c, adding a sunshade to eliminate stray light, figure 7d, and adding a cover for dust mitigation, which is figure 7e. In addition, we're reworking much of the electronics to make them more robust. Now, LEXI is one of 10 science and technology instruments on Blue Ghost Mission 1 that will land near Mare Crisium, as shown in figure 7f, in 2023. Now, Mare Crisium is a 550-kilometer diameter crater in the northeast section of the moon that has a large mass con at its center. And there were 3 prior missions to Mare Crisium. These were all former Soviet Union missions. There was Luna 15 in 1969, Luna 23 in 1974, and Luna 24 in 1976. FIREFLY's Blue Ghost will be the first United States mission to Mare Crisium. In summary then, LEXI, the Lunar Environment Heliospheric X-ray Imager, will land on the moon at Mare Crisium as part of the CLPS, the Commercial Lunar Payload Services Program. LEXI is hosted by the FIREFLY Blue Ghost Mission 1 lander, shown in this figure. And LEXI will observe the solar wind magnetosphere interaction from the surface of the moon to address outstanding problems in heliophysics, such as, for example, the nature of magnetic reconnection. So thank you very much.